Hi everybody, today we're going to go through paper 2013, a question from paper 2 regarding the circle. Here's the question, giving us two circles, C1 and C2, as we can see in the picture, and they're giving us a table to fill where we have the center, the radius, and the equation. So for the first one, C1 is the bottom circle. We know the center is minus 3 minus 2, the radius is 2, and they want the equation. This is just straightforward into the equations formula of the equation. X minus the center, so x minus 3 squared plus y minus 2, minus is plus of course, and equals the radius squared. For 2 squared is 4. So this is the equation of the circle, and at the same time I'm going to draw on my picture also the points, because I like always looking at my sketch so I can see what I found and what I have. For the second circle, then, we have given the circle and we need to find the center and the radius. In this case, we take the coefficient of the x, which is minus 2, and that equals 2g's. Divide by 2, so g equals minus 1. So we're looking for minus g, so that is 1. So my center is 1. That's the x of the center. And we do the same for the y. So minus 2 equals 2f's. Divide by 2, so f equals minus 1. So minus f, which is the center, is 1. And again, for the radius, we use the formula. So it's g squared plus f squared minus c. So g squared in our case will be 1 squared is 1. And f squared, 1 squared is 1 again. And minus c, and c is in our question minus 7. So minus 7 is plus 7. Root, so that's 9. Root is 3. So the radius in this case is 3. And the center is 1, 1. For the second part of the question, they're asking us, find the coordinates of the point of contact C1 and C2. So we're looking for the contact here. There are two options for doing this. One, you do simultaneous equations between the two circles, but that's kind of hard because these are not linear equations, so it's kind of going to be taxing. So therefore, we look at different option. Now, when I see here, I can see I have the point center there, I have the point there, and I know the radiuses are 2 and 3, which I can look at them as a ratio. Therefore, I can use the ratio formula in finding a point when a line is dividing in a ratio to find that point. I'm reminding you the formula. So the formula is in the logbook. It's bx1 plus ax2 over a plus b, and the same for the y, by1 plus ay2 over a plus b. This is in the logbook. So what we need to do now is mark who is our A and who is our B. And I'm reminding you that when we do that, it doesn't matter who you call A and B. A and B are the ratio. So I'm, let's say, calling the bottom part A and the top part B. But it does matter who is x1, y1, because it has to be matching to the A and B. So whoever you wrote A, the guy beside him, which is minus 3, minus 2 in this case, he's going to be the x1, y1. So 1 and A go together. And the other guy will be the x2 and y2 in the formula. So now we're putting it all together into the formula. So it says b, which is 3, multiplied by x1, which is minus 3, plus a, which is 2, multiplied by 1, all over a plus b. That's the x of the point. And then the same thing again for the y, 3 multiplied by y of the point, which is minus 2, plus 2 multiplied by the 1, over 2 plus 3. And you calculate these numbers. So that's minus 9 plus 2 is minus 7 over 5. And minus 6 plus 2 is minus 4 over 5. So this is the point that we're looking for. And they're saying hence or otherwise. So they're saying find the equation of the tangent, blah, blah. Okay, so the tangent that we're looking for is the line that's drawn here. So this is the line that we're looking for. And we have the point on the line that we found now. So in order to find the equation of the tangent, what's missing is the slope of the tangent. So in order to do that, we know the point. So the point is going to be our x1, y1 for the formula will be what we found 2 seconds ago. And what we're missing is the slope of the line. So to get the slope of the line, we'll use the fact, if we had another point on the line, that would be it. We'll use that point, but we don't. So what we will do is we'll find the slope that of the line connecting. Let's say we'll call the line connecting K. Just this line here that we can see. Let's say we'll call that K. We'll use the slope of that line. We'll find that first, and then we'll turn it upside down and change the sign and get the slope of the line of t, because these are perpendicular lines. Always the tangent is perpendicular to the radiuses, so we can figure out what the new slope is. Okay, so we're going to use the other 2 points that we had, the 2 circle points, -3, -2, and 1 and -1, to find the slope. So remember, on the top you take the y's, on the bottom you take the x's, and you get -3 over -4, which is 3 over 4. Therefore, our slope, turn that upside down, so it's 4 over 3, and you change the sign, so it's a minus. Okay, so this is our slope. And then once you have the slope on the point, we go to our formula. Sorry, this is not the formula, this is just a name. So we go to our formula, y minus y1 equals mx minus x1, and we put it in. So y minus -4 over 5 equals m, which is -4 over 3, x minus -7 over 5. So at this stage, it did not say in what format they wanted, so you can do it any format you like. So I'll first of all multiply everything out. And from this side, if you want, you can multiply everything by 15, so you won't have any fractions. I'll do that just for, I don't know why, but I will. And then I'll rearrange and bring everything to the same side. So it'll come out 20x plus 15y plus 40 equals 0. And at this stage, if you want to make it smaller, you can divide everything by 5 or whatever you want, and you can have smaller kind of coefficients, but that's okay to leave it also in this format. And yeah, that's it. Thank you very much, and I'll see you in the next lesson.